Okay, let's practice simplifying some um, imaginary expressions. Here's a few examples. Let's start with, first we need to understand that I is equal to the square root of -1. That's how it's defined. You need to remember that. I squared is just I times I, which is square root of -1 times square root of -1. Well, remember your radicals will cancel, which is just going to be -1. That's a little different, but that's the solution. I cubed, which we probably won't need in this session, is going to be -I, and I to the fourth, excuse me, I to the fourth will simply be, that I to the fourth will simply be 1. And it basically cycles again if I continue with this. I to the fifth is basically like this. I to the sixth is this value, I to the seventh, I to the eighth. It just continues. It's a cycle. And if I wanted to give you I to the 9,000s, you still could simplify this. You'd have to take out all your groups of 4. So for example, if I gave you I to the, we'll go ahead and do this one. Let's make it the 23rd power. Well, you want to break this down of groups of, take out groups of multiples of 4 from 23. So 4 times 5 is 20. So I could say this is really I to the 20 times I to the third, right? Easy. Well, this is your groups of I to the fourth, which is you really have 5 of them, and you're left with I to the third, so your answer for that particular one is -I. Set. What if I gave you 3I plus 5 times 2I minus 4? And then here we have to multiply. Well, we're just going to distribute. That would be 6I squared minus 12I plus 10I minus 20. Here we're going to collect like terms, same way we collect like terms if it was x and y. But your I squared is the only part that's a little different. I squared is equal to -1. So this is 6 times -1, which is now -6. Minus -12 plus 10I is minus 2I minus 20. Now I can combine -6 minus 20. So now I have -26 minus 2I. If I want to find the absolute value for this particular expression, which geometrically speaking is simply the distance from the origin to this particular value on the real imaginary graph, it would be 26 squared plus 2 squared, square root of that. Okay, here's another example. 3 divided by 8i. Well, I would rewrite that as 3 over 8i. And we're going to rationalize. Kind of like when you rationalize the denominator with a radical, same principle. We don't want an imaginary or an I in our denominator. So I'm going to multiply this by I over I, which is essentially 1. So now you're going to have 3I over, well, notice this is what? 8I squared, which is -8. And normally we put our negative in the numerator, so that would be -3 over 8I. And just remember, with imaginary numbers, they work similar to just normal variables. Only your I squared will turn into -1, and that's really the only one you really have to be concerned with. Okay, last example. Here we just have an expression. We just need to simplify this. Easy. 5 minus 2, which is 3. 3i minus negative, well, that's really 3i plus 4i, which is 7i. What if I wanted to find the absolute value? Take the absolute value, 3 squared plus 7 squared, that's 9 plus 49. Take the square root of 9 plus 49, and that'll give you a number, square root of 58, and then you just simplify it. That's it for your review. I try to keep it as simple and to the point so that you can understand the concepts of quadratics and imaginary numbers.